In this chapter, we're going to look at input and output in Java programs. We're going to look at how to format text and numbers in your output, and then how to get input into our programs from the users so that we're not constantly assigning data directly, so that we can have a little bit of variation in the data that our programs process. So we're going to start with some special characters for formatting output, the Newline character and the tab character. If you look at the program in front of you, you'll see that we have our old friend Hello World. And we tell it that in this program, we use the printline method to print the phrase Hello World and then a new line after that so that the cursor moves down to the next line before we output any more text. Another way to do that is to use a special character, the Newline character. The Newline character can be placed inside a string by typing \n. You have to type the backslash first because the compiler needs to know that what follows, the letter N, is supposed to be interpreted as a Newline character and not just as the regular letter N. So when the compiler sees backslash followed by N, it knows that it's supposed to print a new line at that point. Let's compile and run this program. And that's how it works. The Newline character can be placed anywhere in a string. I could put it between the word hello and the word world, like so, and then it'll put the new line at that spot. Let's compile again and run. And so you see that it printed hello, comma, then a new line, then a space, then world, then the exclamation point. The only requirement for the special character Newline is to put it inside a string. So we could also do something like this. We could have the Newline character in a string by itself, \n, close. And then let's compile and run the program. So that it printed the string hello world, then a new line, and then goodbye, and then another new line. So again, the special character Newline works anywhere inside a string. You can place it at the beginning of a string, in the middle of a string, or at the end of a string. The only requirements are that it has to be surrounded in quotes. In other words, it has to be inside a string. The other special character I wanted to look at was the tab character, and that's \t. You use tab when you want to put a uniform number of spaces between your text in a program. So for example, we might have a heading that we try to space out using the space bar. The problem with that is we may not type the same number of spaces every time, so that in the end our output looks jagged and not uniform. We can fix that by using the tab character, \t, where the spaces would be, and then the compiler will insert the spaces for us without us having to worry about if we got the right number of spaces or not. So let's compile and then run. And you see that we have a uniform distribution of day 1, day 2, day 3, day 4 across the line using the tab character. The rules for tab are the same as the rules for Newline. It just has to be inside a string. It can be its own string, so we could write system out print \t and then system out print line day 5. I had the print line there. Let's get rid of that. Save and run it again. So now we see that day 5 is tabbed over from day 4 and added to our output line. So the two special characters, Newline and tab, \n and \t, are useful in formatting your output and can be used inside strings wherever you need them. In the next lesson, we're going to look at some ways to format numbers using two functions called setPrecision and setWidth. Java has a special function or method that we can use to set the width and the precision of numbers that we display when we're printing them out, and that's the printf function. So let's take a look at an example. Here we have a final variable pi, and we've set it to 3.14159.263. If we want to display pi to only, let's say, 4 decimal places, we can use the printf function to achieve that. Here's how we do it. Printf will be used with system.out, but instead of print or printline, we're going to use printf. The way it works is we provide a format string that tells the compiler how to format the number. In this case, what we want to do is we're going to tell it that we want to format the number as a floating point number with 4 decimal places after the decimal point. So we start out with the percent sign. That says that we have a formatting string coming, followed by the 0.4 to say 4 decimal places after the decimal point, and then F to signify it's a floating point number. Then we close the string and put a comma, and then we put the variable pi after the comma. That tells the compiler to replace the format string %.4f with the value that's stored in the variable. So let's take a look at how that's going to display. We'll save it, then we compile and run, and so we see it displays 3.1416, so 4 decimal places. We can set this number to whatever we wanted to set it to, 4, 2, 6, 10, and then it would just put zeros after the last 3 of our value of pi. The second thing we can do with the printf function is specify a width or a field width to display the number in. Notice that when we looked at the number previously, let me pull the DOS window back up, the 3 begins 1 space after the equal sign, just like we expected to, looking at the format string, well, the whole string altogether. If we want to put some space between the equal sign and the value, all we have to do is specify a field width. So let's try one. Let's put this to 5 decimal places, and let's say that we want the width to be 10. So we put the 10 before the decimal place, then the 5 saying we want 5 decimal places after the decimal point, and then the F, of course, for floating point. Let's save it. And let's recompile, and then run it again. There's the run right there. Okay, so you see what it did. Field width of 10 means that the whole number, including the decimal places, will fit into that width. Let's change it to something a little more extravagant. Let's try 20, just so you can see how that field width works. So we'll compile, then we'll run there. And if you count it out from the first space after the equal sign through to the last 9, then you'd see that was fitting into 20. So using the printf function, we can specify a field width and the precision of a number. A lot of times all you'll see is the precision itself, or sometimes all you'll see would be the field width by itself. Let's print that out to see what it does. Notice that the default is 6, which is actually less than the whole number, but that's the default value because we didn't specify. Let's go back and look at the format string. We didn't specify the number of digits, so it defaulted to 6. We could have said 0.1. And again, I'm doing this just to demonstrate the differences in the format strings. And then we could have taken out the field width altogether. Let's change that to 2, just for demonstration purposes. So that's how you use the printf function to specify precision and field widths. To be perfectly honest, printf is a holdover from the C++ language. And I may have mentioned before that Java was designed a lot around C++, but most Java programmers don't use printf unless they're printing out lots of rows and columns of numbers where the specification for a format is very important. Normally, except for maybe the number of decimal places, which there's other ways to control, printf is not used all that much. That finishes the output portion of this chapter. Now we're going to move into input, and we're going to learn how to get input from the user using a special class called the scanner class. In this lesson, we're going to learn how to retrieve input from the user at the keyboard. This has lots of uses, both practical and real world, in that you cannot constantly be assigning data in your programs. You need to be able to ask the user to enter data and have the program store the data that the user types at the keyboard. And in real-world programs, you're not going to be assigning data all the time anyway. You're going to be getting input from the user. So learning how to do this is quite important. To get input from the user at the keyboard, we have to import a class called the scanner class. And importing involves writing a line of code at the beginning of the program, at the very top, above the public class, where you type the keyword import followed by the name of the class, in which case we want the scanner class. And notice I didn't just write import scanner, I wrote import java.util.scanner. Java.util is a package where the scanner class is located. By putting classes in packages, we can use method names and other identifier names over and over again without causing any conflicts. So the different classes that make up the libraries of Java are all located in different packages, and the scanner class just happens to be located in java.util. Once we've imported the scanner class, we're ready to actually create a scanner object, and that's how we get input from the user. We create an object of the scanner class and then use that to get the input. So to do that, we're going to declare a new object, and we'll call it input, and then we call the constructor for the scanner class. And what the constructor wants is a input object, in this case the keyboard, which is represented by system.in. You've seen how Java represents the screen by system.out. Well, the keyboard is represented by system.in. So by writing this line of code, scanner input equals new scanner system in, we're saying that we want to associate the object input with the keyboard. Now we're ready to get some data. So let's first create a integer variable number, then let's retrieve that number from the keyboard. The way we do that is we write a method from the input object called nextInt. What happens is when the compiler comes across this line of code, when it sees nextInt, it stops the program and lets the user enter a number at the keyboard, press enter, and then at that point that input is assigned to the variable on the left-hand side of the assignment statement. So we can verify that that works by having a system out line right here, where we'll just echo the number back out. So let's save and run this program and see what we get. So we compile it, tap 7, part 3.java, and then run it. I didn't put a prompt in here, so we're just going to enter a number. A prompt probably would have been a little bit better. So we type in 45, and then it goes back, the number is 45. Why don't we do this? Let's just go ahead and write a real simple little addition program. We're going to create two integer variables. Then we're going to, let's create a sum variable also to store the sum. Now let's prompt the user, systemout.print, enter the first number. Then get the number with input.nextInt. Then we're going to prompt the user to enter the second number. Number 1 gets the next integer entered, like so. Then we can compute the sum, number plus number 1, and then we can write out system out print line. The sum is, I won't put the numbers back up there, and then we can just delete this last line, like so. Let's save the program, compile again, and then run it. So we'll do 23, the second number will be 56, and the sum is 79. We can work with floating point numbers just as easily as we work with integers, simply by changing the method that we retrieve numbers with. So if I want to do a double addition program, all I've got to do is change my declaration to doubles and then change the method from nextInt to nextDouble, like so. And that's all we have to do. Save the program. Now let's compile and run it. We'll enter a 0.34 and 2.56, and it says the sum is 2.9. You can also mix data types using the input object just like you can in assignment. You just have to be careful. You can assign integer values to double variables using nextInt into a double, but you cannot assign nextDouble inputs into an integer because of the loss of precision. So the same rules that apply to doing mixed math in Java also apply to entering numbers into variables in mixed ways. So you can put an integer into a double, but you can't put a double into an integer. So to review, the key to getting input from the user is to import the scanner class. Be sure to set up an input object. It doesn't have to be called input. That's just a variable name. but some object that is associated with system.in using the scanner class and its constructor, and then calling the appropriate method, either nextInt or nextDouble, to retrieve the number from the keyboard. So that explains how to get numeric input from the keyboard, and in my next lesson we're going to learn how to get string input from the keyboard. Strings can be entered into Java programs just like numbers can, using a scanner object and the appropriate method. So let's demonstrate how that works. First thing we have to do, again, is import the scanner class. So we write import java.util.scanner at the top of our program. Let's enter a name into our program. So we're going to create a string variable called name. Then we have to create a scanner object. We'll do that. And again, we associate that object with system.in. Now let's prompt the user to enter their name. Enter your name. Then we retrieve the name from the keyboard using the input object and the method next. Next will receive the next input up through the enter key and store it in the receiving variable that's on the left-hand side of the assignment statement, like so. And then we're going to write out the name that the user entered. Your name is plus name, like so. So let's save the program, then go back to the DOS prompt. Let's clear the screen, compile, and then run. Enter your name, so I'll just enter my name, Mike, and your name is Mike. Now that works great for my first name. Let's try it if I enter my whole name. Whoops. What happened was, just like I said earlier, the next method receives input up until you hit the enter key, or it finds a space. So the actual delimiter is a space, delimiter just being what separates two or more pieces of input. In this case, next is looking for a space or the enter key, and when it sees that, then it decides that's all the input I'm going to get, and it shoves it over into the variable that's receiving it, or whatever else you're deciding to do with that input. If we want to retrieve more than one piece of string data that's separated by a space, we need to use a different method. That method is called nextLine. So what I'm going to do is I'm just going to add that into our program right here. Save the program. Let's compile it again, and then let's run it. So now if I enter my full name, it works. I can enter part of a name, and it works. Or I can enter my real full name, and you'll see that nextLine will retrieve everything up until the enter key. So spaces or any other punctuation, any other delimiters, although space is the only real delimiter for the scanner class, any other spaces are ignored up until the enter key. So you can use the next method when you know that you're only getting a single word as string input. But if you're not sure, or there's a chance that there's going to be a space in it, then you need to use nextLine. So to review, to retrieve strings from the user, we have to import the scanner class. We need a variable to receive the string. We need to set up a scanner object to associate with the keyboard. Then we retrieve the input using either the next method or nextLine if there's a chance that there could possibly be a space in the input. And that's really all there is to entering strings into your programs. The next lesson will be an exercise where we work with the input methods that we've learned so far. Let's close this chapter with an exercise where we create a form letter to send to people who've given us a present, say for a birthday or something. I know that's not a very personal touch, but it gives us a chance to play with input and output a little bit. So on your screen you see the letter that I've written. What I've done is wherever there's a variable, I've replaced that or begun that variable name with the $sign so it'll stand out in the letter. So it says, dear name, that's our first variable. Thank you for the present, that's our second variable. I really like it. I can't believe that I'm already age years old, but it doesn't feel that much different than being age -1. Do that in just so we could do a little arithmetic. Thank you again for the present, sincerely, and then your name, That's our last variable. So what we're going to do is write a Java program to prompt the user to enter this data and then recreate the letter. So let's get started. I've begun the program already. The file name is letter.java, so my public class letter starts this. Before I can start the program, though, I need to import the scanner. So we're going to write import java util scanner right here. Now we're ready to begin the program. First thing we need are some variables. So we need a variable for the name of the person giving us the gift, the present, and then the name of the person running the program. Then we need an integer variable for the age that the person is on their birthday. So those are our variables. The next step then would be to input the data into the program so that we can write out the letter. So we'll begin with the prompt. System out print. What is the name of the gift giver? Oops, left out a step. Actually left out two steps. Before we can do prompting, we need our scanner objects. Now, one of the things about Java is that the scanner doesn't work that well when you mix numbers with strings. So what we're going to do is we're going to create two input objects. One called input string. Let me finish that one. And use it to get our string data into the program. And then we're going to do another one for numbers to get our numbers into the program, although there's just one number, the age. Okay, so there's our two scanner objects, input string and input number. So now we prompt the user to enter the name of the gift giver. Name equals input string, next line. Then we prompt the user to enter the present. Present equals input string, next line. Then we prompt the user to enter their age, or how old they were on the birthday, on your birthday. Age equals input number dot next int. And finally, our last piece of data is enter your name. Okay, and that should be all the data that we need. So now we're ready to write the letter. So the first thing we're going to do is put a couple of lines between our input and the output. We'll write a couple of print lines by themselves. That'll give us two blank lines. Then we begin the letter. So system out print line dir plus name, because we're going to concatenate that variable data to the string, plus a comma and a space, and then close the system out print line. Then a couple of spaces, or at least one, so let's just copy. We're going to use this a lot, so I'm going to go ahead and copy and paste it in, then I can do it every time I need to put a space. There's going to be a few. So then the letter starts out, system out print. This time I'm going to use print because I'm probably not going to be able to fit all this on one line. Thank you for the present, and then a period and a space. I'm not at the end of the line on my editor, but I'm close enough that I don't want to start another line. Then system out print line this time, because I probably will get to the end of the line. I really like it. I can't believe, and a space, and then close it out. Drop down to the next line, system out print. I'm already plus age, years old, comma, but, and then put a space, and then close that. Come down to the next line, system out print line, but it doesn't feel that much different then. And that's the whole line there, so we stop, put a space, system out. This is a short line, then being age -1. Sometimes Java has a problem when you put an arithmetic expression in a string concatenation, so putting the parentheses in there should help me with that. And then a period, close that line. Then we need a blank line. Then we write out the word sincerely, comma, then a blank line, and then our name. And it could be a print line or not a print line, it doesn't matter, your name. And I saw where I made a mistake up above. I did name twice. This would be your name right there. Okay, so let's see how that works. So we're going to save the program, file save. Come back up here, let's clear the screen. Java C letter.java. No errors. So Java letter. What is the name of the gift giver? Aunt Jean. What is the present they gave you? Well, that's okay. Sweater. How old were you on your birthday? Let's say 13. What is your name? Let's say it's George. And there's the letter. Dear Aunt Jean, thank you for the sweater. I really like it. I can't believe I'm already 13 years old, but it doesn't feel that much different than being 12. Sincerely, George. So that demonstrates how to use input and output together. We didn't use the tab or the Newline characters. Those really aren't used all that often in Java programs. But this is a good example of a typical session of input and output with numbers and strings. So that wraps up our discussion of input-output, and now we're going to move to the next chapter, which is on decision making using if statements and relational operators.